access and open source tools for geographic and transport research. And I think there's an interesting, like Venn diagram between geographic tools and transport tools. I've often been surprised at how small the intersection is between geographic research and transport research, not least because transport research is literally the study of moving from one place on the planet to another. So it's kind of inherently a geographic enterprise. So the kind of starting point is that I think that geographic tools and analysis have a huge amount to offer transport research. And just by way of a blank slate introduction to myself as well, to provide a bit more background, I studied geography at undergraduate and was actually frustrated at times at this, what I saw as an artificial division between the human geographers, the so-called human geographers, and the so-called physical geographers, and the way that the modules and the way that the course was structured really encouraged people to pick from one of these two camps that were often not really, were speaking totally different languages with like very sociological language coming from the more human geography side that was difficult to understand. But then conversely, coming from the science side, a lot of kind of glaciology analysis and blinding people with science, so equally difficult to understand kind of communication coming out of the physical geographers. And I was kind of stuck in the middle thinking, well, surely these two sides of geography are equally important, and the whole point of geography to some extent is to combine them. So that's where I'm starting from. I didn't actually get into coding until relatively late, I think, compared with a lot of people in the data science area. It was actually because I needed to solve a specific problem during my PhD, and I simply couldn't solve those problems using the tools that were available. So that's why this is about tools. This talk is primarily about the tools, because the tools that you use and have available have a huge impact on the research that you are able to do and the amount of creativity that you can do. And yeah, so like it is about the tools. And as is typical, I'm starting with a problem in this talk. So in terms of the geographic data, I think we do have a problem in the sense that the industry is fairly divided and polarized between a few large players, and by far the biggest commercial proprietary software company in geographic data is ArcGIS, and they've been in the industry for a long time. But if you look at their business strategy, I think it is problematic from the perspective of freedom of data, and also in terms of equal access to data processing resources. So like many digital companies, that they are starting to provide their services as a cloud-based resource. So you pay per minute of use, and you can buy like 1,000 credits, and then you can do your analysis in 24 months. And then if you use up a certain amount of credits, you have to pay for more stuff. And I don't think I need to go into too much detail of various situations where that could be problematic, not least because not everyone has the same amount of money. So it inevitably favors people who are able to buy more credits to do more analysis. If you want to use a more advanced tool, I think you have to pay for like an extension. So this is clearly a problem. The great thing about these slides is I'm going very quickly from problem to solution. So yeah, we know the solution, and they're doing really well. There's a thriving ecosystem of open source tools for geographic data analysis, and I think it is just worth taking a little look at some of these tools. So Yeah, QGIS. I've been using QGIS for probably over 10 years now. It's, I believe, by far the most popular open source geographic project, and it is a thriving community. You've got hundreds of contributors, and it's a very well-known tool that can solve a huge number of problems, and it's got a very diverse plugin system. So if you can't find the solution in QGIS, there's a good chance that you can find somebody who's solved the problem. And if I get time at the end, I would love to do a bit of a live demo with QGIS, because I think it's an absolutely great tool. I owe the QGIS developers a huge amount, because I learned a lot of my geographic data analysis skills and concepts using QGIS. So I think that's probably the first place to go, especially if you're new to geographic data science. It is absolutely rock solid, and you can go and download it and install it if you're working with geographic data and you haven't done so already. And then a few other players that I've got on the screen here. One of them is OSGeo, and OSGeo is kind of like a meta organization that is binding together some of the most important geographic data processing tools in the world, including QGIS actually. So this is their homepage, and they're basically an organization that helps to fund, helps to coordinate development between these various projects. And there's some really important like infrastructure tools going on here. And without going into the details, a large proportion of geographic data science is driven by a few core libraries. So you've got something called, it's spelled GDAL, and it's pronounced GUDAL, which is a C++ library for reading and writing a vast range of geographic data formats. So if you've got a geographic data format, 9 times out of 10 you can read it with GUDAL. But the problem is, from a user perspective, it's difficult to use a C++ library directly. So for that reason, you have interface libraries such as QGIS, which integrates quite closely with GUDAL. And another one alongside GUDAL is Geos, which powers a lot of the kind of geographic operations. So if you want to find the intersection between two different geographic layers, there's a C++ library called Geos that will do that. So it's really great that we've had this consolidation rather than many different projects that are kind of scattered and not working together. OSGeo really is the umbrella organization that's holding them together. And I'm very glad to hear someone's already mentioned the other project that I've got here, which is SF. So that is the R representation of this well-defined data format called simple features. And this is basically covers 90% of the vector geographic data that you find in everyday life. So points, lines, and polygons essentially can all be represented in this. It's like a representation of the geographic data, and it's got an implementation that is actually a very good implementation in the statistical programming language R. And yeah, there's a mature community behind it. It's the issue tracker is very actively maintained. So yeah, that's just a great community. And then also on the Python side, you've got moving pandas, which is the Python equivalent of SF essentially, and you've got various Python packages that build on that, such as moving pandas, which is quite a notable success story that builds on the SF class system. So they are the solution to this problem. Okay, so you may think, well, what's the issue? And this talk is obviously part of the reproducibility. So a long-standing problem with stuff like QGIS and geographic information systems in general is that they have historically relied on graphical user interface. So that map that I showed with QGIS, you interact with it by moving your mouse and clicking on things. That's great for quickly getting started and for making maps, but it isn't particularly good for reproducibility. So this is where kind of programming with geographic data comes into play. And the word that I use for this is geocomputation, which is just essentially doing computation on geographic data and trying to think in a computational way about your geographic data. And yeah, this is an open source and completely reproducible book. So I think it's a good example of how the concept of reproducibility can go beyond just making a single paper reproducible. You can actually make all kinds of documentation reproducible, including entire books. So again, this is kind of another plug. And if you want to get started with geographic data at the command line, I can recommend this book, not just because I'm one of the co-authors, just because we've had it out there for some time and it has withstood the test of time. So check that out. And that basically covers the introductory steps that you would need to take to think about doing geographic data analysis at the command line. So we try not to make it too language specific. We provide a general introduction to the history of how people started using open source software and integrating it with these command line tools. So R is a statistical programming language, which means that you've got access to a whole load of statistical analysis packages in the box, basically. So yeah, that's just one place to get started, and that's where I'm coming from as a R user. But this talk wants to be a lot bigger than just talking about one specific language, which is R. The higher level concept here is that this is open source software, meaning that it's got a community behind it, and to some extent the community is more important than the technology. So there's a huge amount of learning and communication going on in this space. And one thing that's been really encouraging recently is this shift in the R community to try and become more diverse and to try and become more integrated with other parts of the open source ecosystem. So a good example of this is actually something that I've proposed, is that the R spatial community is certainly growing, more and more people are using it, but we are not very well integrated as a sub-community into the wider process. So we have recently basically sent a letter to OSGeo saying, can we link up here? And I think this is a really great example of integration within the open source community. And one thing that I think's important in terms of reproducibility and open source, and I think that the two concepts go hand in hand, is that when you're working on using open source software and you're working on an open source reproducible data analysis workflow, I think that you tend to have a more collaborative mindset. So rather than thinking, okay, how can I compete with this alternative, I'm always thinking, how can I collaborate with these guys? So for that reason, you've seen a huge amount of kind of consolidation and learning from the different sides of the community. And a typical example is this idealized R versus Python conflict, which in reality doesn't exist at all. I think you see a lot of mutual learning between the R spatial community and the Python spatial community. So that's some opening comments that I've got about open tools for geographic research. I think that's a good kind of overview of the landscape, and there are lots more tools than just this sample. I think these just provide a good kind of insight, but there are literally hundreds of tools out there, including many QGIS plugins. If I had to name a couple of others, I would say the GeoRust community is trying to build low-level alternatives to some of the OSGeo low-level packages. So I've mentioned those, and then there's a open source project called Whitebox Tools, and then there's also various interfaces to online cloud-based processing tools like the Google Earth Engine, which is a really powerful framework provided by Google. But I'm not going to go into that now. What I'm going to talk about is how these geographic tools can link in with other areas of research. And I'm aware of time, so I'm going to speed up at this point. So transport is the domain that I'm currently using these methods to research and understand. And I think while the geographic community is fairly well advanced in terms of there's a vibrant, lively community, in transport it's much more early days. I think partly because a lot of transport research is done by consultants who don't always have an incentive to make their work reproducible, or let alone to use open source software. So this is a really big problem for society. Basically, if our transport plans are all coming from proprietary software that is not conducive to reproducibility, you can end up with bad decisions being made. You can end up with even a lack of transparency, which has implications for the extent to which transport planning is democratic. So these are really big things that the choice of tool can affect. So yeah, I'm not going to go into this anymore, but like the main point here is that it's understandable how this situation arose, given the fact that open source software is a relatively new concept and transport modeling has been around since at least the 1960s. And those transport tools and the concepts behind them are generally proprietary, and they're generally focused on problems that were around before the 21st century. And now we've got totally different priorities. We need to decarbonize the transport system. We need to we know that people need regular physical activity to tackle the obesity crisis. So therefore, we need new tools. So as I showed with the geographic data problem, I think the solutions are actually pretty clear in transport as well. So this is really a recent tool, but it represents, I think, the direction of travel for open source tool development in transport planning. And this speaks to Kieran's research. It's an agent-based, relatively simplistic agent-based modeling framework that is written in Rust, and it's evolving very, very quickly. So this is AB Street, and it basically allows you to represent an entire city on your computer. And because it's using WebAssembly, you can even represent moderately large transport systems in your browser, which is pretty amazing. And if I get a chance at the end of this these slides, I can do a quick live demo of AB Street in action. So again, we have these solutions, and this is the paper that was sent around. So it's basically providing a summary of the landscape of open source tools for geographic analysis in transport planning. And it's, yeah, really exciting to watch all of these tools emerge. Some of them are quite new, some of them are quite radically different from the previous tools. So I think it's a really exciting time to be doing research in this area. And another thing about the paper itself is that it was actually part of a special edition about open source software for geographic analysis, and partly to make the point about if we're going to write about open source tools, we should actually make the manuscript open itself. So I've made an effort here to make the manuscript open access, so you can find that on GitHub, which is just a feature of it. And I've been surprised how many people have kind of commented on the manuscript. So that raises the question of, should we be thinking about going beyond just open sourcing our code, but actually open sourcing our research as well to make it more participatory? So yeah, like that paper, I think, stands for itself. Basically, the message is that there is an emerging ecosystem of open source tools. There's 3 broad categories of tools, and those are graphical user interface based, command line interface, and then this new breed, which is the web user interface, which is where the AB Street tool is coming from. But I'm not going to kind of dwell on that, because you can read the paper, and it provides, I think, a useful state of the art and a kind of call to action that this stuff exists, but the question is not so much technical, it's more policy and political. How do we encourage people to use these tools? How do we gain some kind of consolidation within this wider community? And one thing that it doesn't touch on so much, the paper, which I think is a limitation of this paper, is the concept of open access. So while many of these tools that I talk about in that paper, such as Moving Pandas, OSMNX, and Sumo, these are popular packages. The problem is that they are pretty inaccessible to the majority of people. And that concept of open access software actually originates in research by a guy called John Lindsay, who's based at the University of Guelph in Canada, and he's developed over many years various open source GIS systems, such as Whitebox, GAT, and more recently the Whitebox Tools Rust package. But the main point that he makes is that it's the responsibility of people who are making tools to not only publish the source code, but tell people how to use them and make them available for use. And I think that's something that myself and other people who are working fairly close to the cutting edge need to take more account of this, of the importance of open access. So yeah, that's a follow-on concept. So yeah, I think that's just something to dwell on. And what we mean by open access is that not only is the source code available, there's a very clear use case where someone, and not necessarily someone who's an experienced programmer, could take what you've done and put it into practice. And I think the web user interface tools really help with that. I think the graphical user interface approach of something like QGIS really helps with that. So yeah, I've got a few other comments about science and about the various contrasts and differences between proprietary and open source software. But I think, speaking to the reproducibility audience, I don't need to dwell on that. I think you already know that reproducible and open research is more scientific. So I've got a few brief comments on how you actually go from thinking about tools and using tools to actually build them. And the first thing to say that's represented in this GIF from The Simpsons, which is where Homer Simpson gets this really nice barbecue kit, and he's got this vision of like a really perfectly working barbecue, and then it just ends up with this big mess on the floor. And I think that is an important point. Like, it's not going to work first time. Writing software is hard, so it should be taken like slowly. Don't try and build a really complicated source code first. Start with a prototype. And a great example of this is the propensity to cycle tool, which is, I think, both an open source and an open access geographic tool in the broadest sense of the word, and it's certainly accessible because anyone can just access it through this website, pct.bike. And this goes back to what I was saying earlier about I'm not actually a computer scientist, but I've learned about computer science basically by solving problems and realizing that if I didn't learn some computer science concepts, my projects would fail. So yeah, that's the propensity to cycle tool, and the point that this image is designed to get across is that you need to start with a prototype, and probably it's best to start with a pen and paper and forget about the technology and just think about the tool that you want to create. And that's a process of design that transcends the technology that you use to implement that design. So it's basically going back to the design side. I've got a few reproducible, of course, lines of R code here just to show the general structure of the data that we're using in the propensity to cycle tool that I think could be useful for other types of data analysis as well. So without describing the code in detail or at all, because I want to make time for questions, there's a data analysis pipeline where we're writing reproducible data analysis code, and then we're coming up quite quickly with a result which is looking for car dependent areas within West Yorkshire. And you can see here that we've pulled out some areas where you've got over 50% of trips between two areas that are less than 3 kilometers apart being by car. So those are problematic areas and potentially interesting areas from a research perspective. But the work that I'm doing, work is usually the most exciting work you're doing is usually the most recently begun. So the final thing that I want to show is something called ActDev, which is a new tool that's kind of inspired by the propensity to cycle tool, but also integrates with the AB Street traffic simulation modeling software. And that's something that I would like to show, but I think I'm going to open it up to questions. I'm sure some of the questions will allow me an opportunity to demonstrate this latest tool that we're working on. And this is really exciting stuff because we've been working on it for the last 3 months, and finally we're getting to a stage where we think it is usable by the public almost, and could hopefully help create more evidence-based decision making around new development sites. So I'm going to kind of leave that there without going into an in-depth live demo of this latest project, but I think it's a great illustration of how this open source ecosystem that I'm talking about is ready to go. It's already out there, and I think to some extent it's just a case of using the existing tools and communicating them rather than trying to build constantly looking for new tools. We've got very, very good tools already in the geographic data analysis space, but I think to some extent it's a question of people understanding them and communicating them and using them in a policy relevant way. So my final slide, or my final proper slide, is just a call to action of how to get involved. So obviously just communicate and find a open source project that you're interested in, and you can sign up to platforms like GitHub, which is increasingly easy, and you can just start asking questions. Sometimes just asking a question on an open source issue tracker can help the developers identify issues and find improvements in their code. It's important to ensure that you are being constructive if you ask questions on an issue tracker, but I think sharing the knowledge and simply teaching other people what you've learned can be a very empowering and useful way of contributing to the wider open source ecosystem. And obviously I've got to end with a plug. As a R user and advocate, I recommend, if you want to do reproducible data science, R and RStudio is a great place to start if you're new to all of this stuff. So have a play with the web tools that require very little prior knowledge to get started with. So with AB Street, you can simply go on their GitHub page and then click on the web browser, and you've got an interactive geographic data-based web tool in the browser, which has crashed in the spirit of live demo. And yeah, get involved. So I've got a few references, and very happy to say that I've finished in time to allow a few questions.